It's a great day, grade 10s, to continue with measurement calculations. So the last couple lessons, we've been talking two-dimensional shapes, just getting perimeters and areas of those shapes and using the formula. Well, today we're going to move on to three-dimensional shapes and start talking about surface area. Now, if we talk surface area is the exposed surface of an object. So you'll hear me talk, when we talk surface area, a lot about if you were painting this. That's how I've always considered surface area. When you have an object that's three-dimensional, if you are covering the entire object with paint, everything that gets paint on it is the surface area. So what we're looking at and we focus on are prisms. A prism is a 3D shape that has bases or ends that are congruent. So we have two ends that are the same, exactly the same shape, and they're parallel to each other. And we'll take a look in a second. But all the bases are always attached by rectangles or sides. So these are solid three-dimensional objects. They have the length, the width, and a height to them. So that's what we're going to be working with, prisms in this lesson. It's important you understand that prisms are named for the type of base they have. If you have a rectangular prism, well, the fact that it's rectangular tells us the base shape is a rectangle, and you will have two of those, because base, we always have two that are exactly the same. And then we have rectangular sides. Well, a rectangular prism would mean we have a rectangle base, so two of those. So I could have two of those, and then I connect my vertices. There's a rectangular prism. The rectangle base, and then because our base has four sides, there will be four rectangles that go around connecting the two bases that are the same. So that's what we're looking at with prisms. A square prism, well, it's going to have a square base. And again, two of them. If I have a square base, and it doesn't always have to be the top and the bottom that are the base, as long as I have two of them across from each other. So in this case, here, there's where I have my square base, and across from it, exactly the same size, I have two square bases. And then I would have four rectangles going around to connect them. So that's what we're looking at with prisms. Pause the video, take a minute, see if you can finish this chart. Trapezoidal prism. Well, trapezoidal prism, a little bit more complicated because you haven't done a lot of work in the past with trapezoids. But if we were looking at a trapezoidal prism, remember a trapezoid is a quadrilateral that has one set of parallel sides. And now to make it three dimensions, you can always do a three-dimension graph or chart, diagram, by drawing the same shape, our bases across from each other, and then just connecting the appropriate vertices. And there's a trapezoidal prism. Trapezoids for bases because there's two of them that are across from each other, parallel and identical. So it's a trapezoidal prism, two trapezoids, and because there's four sides going around, we would need four rectangles to go around. So our base shape is the trapezoid, and we have four rectangles for sides. Triangular prism. triangle base, and connect. And what do we have? If it's a triangle base, we have a triangular prism. And how many rectangles would we need? Well, if there's 3 sides on my base, I would need 3 rectangles, the left side, right side, and the back. So 3 rectangles. And the last one, name of the prism. Well, if we have a base shape that's a circle, there's a circle, there's another circle, and there you go. So the name of the prism is a cylinder. Some people will call it a circular prism, but really, it's just a cylinder. And how many rectangles are there? Well, we'll see cylinders in the next lesson, but they're kind of unique. There's just one rectangle on a cylinder. So that's what we're looking at working with, prisms. Being able to name prisms or recognize them will be important. To calculate the surface area of any one of these, if I were painting any one of these shapes, the surface area would be what's the amount of exposed surface that would receive paint. So to get surface area of the 3D object, it is going to be the sum total, add up all of the areas of the faces of the object. Surface area can be easy to calculate if you're able to visualize the 2D shape. That's the hardest part, is understanding what are the 2D areas, two-dimensional areas that we have to total up. So identifying the faces in a prism is tricky. That's what I find most of the error happens in these questions. It can help to visualize the net, which is the unfolded version of a 3D shape. That shows us what there is making it up. So if we started with a rectangular prism and we unfolded it, this is what it would look like. So we would have 6 different faces. We would need to calculate the area of each face and then total them. Now you're going to see when I go into this, I'm not going to be so focused on actually having to draw a net. But what I'm going to focus on as an organization step is knowing what the faces are, sketching them and identifying how many of each face you have and what their dimensions are. If you can get organized first, the calculations are easy. So when we even take a look at this first rectangular prism up here again, what do we have? Well, in terms of, we can see the net, but I look and see, I could consider these to be my bases. I have 2 of those. So I have a triangle or a rectangle, and I have 2 of them that are my sides. But I also have 2 different sized rectangles here that are opposite each other. So I have another 2 different dimension rectangles that are the top and bottom. So identifying what you have can be beneficial. And the last one we have is we have the back rectangle and the front rectangle are the same. So again, those would be different dimensions again, and I have the front and back. So with a rectangular prism, we can see in our sketch, yeah, there's 6 rectangles, but I need to make sure I identify that there are 3 different rectangles with 2 each. So sketch the net of a triangular prism. Well, what would it look like? A triangular prism. We would have a triangle, we would have a congruent triangle, and we could then connect those pieces. There's the prism. If you unfolded it, well, you would have a triangle that's attached to a rectangle. So that could be this front triangle and then the bottom rectangle are attached. Well, this bottom rectangle is going to have a rectangle on either side of it, and opposite it, another triangle. But what's going to be important for me when we're looking at these? Know that there's two triangles that are the same. I can put triangle times 2 because they're congruent, because those are my bases. And then I have 3 rectangles. So let's take a look at some examples on the next page. So we've already seen this example, like I just did the sketches of it, but let's now do the work. Identify the shapes and dimensions of the face. Well, I look at the sides. I have 3 wide, and this here is the height, which we see as 4. So I have a 3 by 4 rectangle, and I have 2 of those. The sides. What else did we talk about earlier? We talked about the fact that the top and bottom are different than our sides. We can see the bottom rectangle is 5 by 3. So we have a 5 by 3 rectangle, top and bottom. So there's 2 of those. 5 by 3 and 2 of those. What are we missing? Well, we have the front and the back are the same. The front is 5 wide and 4 high. So we have a third rectangle that's 5 by 4, and we have 2 of those. What's nice is that once you've taken your 3D diagram and sketched the faces, you don't need this anymore. You don't have to try to analyze what it is that you've worked with, because everything you now need for the surface area calculation is right here. This organized step is essential. This is, I find, where probably 80% of the problems in students' work occurs. Not calculating or not identifying faces properly. The calculation's not too bad. So what do we have for surface area? Again, I like to think in terms of words. I have 2 rectangles, 2 different rectangles, and 2 more rectangles. This is not necessary, but it's a nice organization step. What you do have to put is I do expect to see a single equation for the calculation that's going to be done. I don't want to see, oh, I'm going to go LW times 2 here and then LW times 2. I don't want to see everything scattered around. An expectation for surface area is being able to create one equation for the situation. 2 rectangles plus 2 rectangles plus 2 rectangles. There's the equation, and then I expect to see a substitution step. But everything I need is over here. My first rectangle would be 2, 3 times 4s. Dimensions are 3 by 4, length times width, 2 3 by 4s, plus the next rectangle, I have 2 of them, times their area, which is 5 by 3. And then the third rectangle, 5 by 4, I have 2 of those that are 5 by 4. I expect to see a single equation, substitution step, and then an answer. Show your work. 3 times 4 is 12, times 2 is 24. 5 times 3 is 15, times 2 is 30. 5 times 4 is 20, times 2 is 40. So our surface area for this particular rectangular prism is 94 centimeters squared. That's the process I want to see. Show your sketches, organize yourself. Single equation to represent what you're doing, then substituting in and solving. So example 2, let's work through that one together. Example 2 says we have a cube. What's a cube? Well, a cube is a square prism, but a cube is special because it's a square prism, but all the sides are the same. So we have 7-inch sides. It's like having a dice. All the sides are the same. So start. What shapes do we have? Well, the shapes that we have in this, we have a square that's 7 by 7. How many of those do we have? Well, every side in a cube is 7 by 7. So how many sides on a cube? There are 6 of them. So we have a 7 by 7 square 6 times. So the surface area would be 6 squares. So my formula would be 6 times, and the area of a square is s squared. So 6 squares, 6 times 7 squared. 7 squared is 49. 49 times 6. We would have 294 inches squared for the surface area. Sketch what you have. Make sure you know what you're working with. Substitute into the formula what you have to get your final answer. Last example, number 3. Pause the video, give it a try. This one's a little tricky. Some students will miss some things. Let's see if you can do it. Pause the video, give it a try, and then we'll do it together. So to start with, we need to identify what we're dealing with. Well, we have triangle bases, because that's what we have 2 of, across from each other, parallel to each other, and congruent. So I have triangle times 2 of them. What are the dimensions that I need, though? Well, we see that we have 8 for this side length, 4 for that side length. That 6 matches up there, so that's 6. And then we have a 3 centimeter through the middle. 8, 4, 6 triangle and a 3 centimeter through the middle. Well, what do we need from those? We don't need all of them right now for our triangle. Remember a triangle formula, 5/10 base times height. Well, what's the base height? Well, 3 is the distance from a vertex to the opposite side, and the height always meets the base. So right now, the 8 and the 4, they're not needed for the triangle. What we need for that triangle is the base of 6 and the height of 3. So that's all I'm going to put into my sketch. Nice and organized, so I have all the information and only the information I need when I go to calculate. So there's my start. What else do I have? Well, every prism has rectangles. So here's the biggest problem I find students have. They see the 6 by 16 rectangle. There I go, done. I have a 16 high, 16 wide, 3 rectangles in a triangular prism, and I'm good to go. But at this point, you're not. And hopefully you're sitting there looking at the video saying, McDonald, you're doing this totally wrong. Well, I'm not doing it totally wrong. But we do have this 16 by 6 rectangle in the front. However, you need to take a look and analyze these sketches. This is where the problems occur. If we look to the left side that sort of has the rectangle, the left back, I'm going to outline it, and there's the rectangle that's in the left back. It's not 16 by 6. It's 8 by 16 high. So our second rectangle is 8 by 16. Now, what's the third rectangle? Well, again, you need to stop and think a bit. This is why the sketching and organizing is so important. The back right side of this sketch, there's the other rectangle. It has a width of 4 and the height of 16. So we're looking at another rectangle that's 4 by 16. So there's the 3 rectangles. I don't have multiple of any one of them. I just have one of each. So you need to really take your time, look at the diagram, and figure out what you're dealing with. So now, there's my sketches. I need a single equation. Well, my first organization step, I have 2 triangles plus 3 different rectangles, so it's important I identify that there's 3 separate ones. Now I can put my formula in. This, again, an optional organization step. It just helps me to eliminate errors, I hope, and I find. Well, I have 2 triangles, 5/10 base times height, plus a rectangle, plus another rectangle, plus a third rectangle. And there's a single formula that will work for the surface area of this shape. Being able to put this information as a single equation is important. Now I can plug in. But all the information I need is in my sketches. I don't have to try to analyze over here anymore because everything I need for that formula is in my organization. I have 2 times 5/10 times base times height 6/3. It's all right there. Plus an LW, a 6/16. Plus an LW, an 8/16. I'm going to have to continue it down here. 8 times 16. Plus the third rectangle, it's right there, a 4/16. Everything is nicely organized in my organization step. Now I calculate. So in this case, 2 of those triangles, 18. 6/16 gives me 96. 8/16 gives me 128. And 4/16 gives me 64. And when I add all of those together, the total surface area for this triangular prism is 306 centimeters squared. Organize first. Single equation. These are things that will help eliminate errors. Your assignment, booklet, page 46, and supplemental pages, that packet of extra work, page 11. There's what your assignment is. Practice it. Not overly complicated, but enough complication you need to practice. And have fun with it.